Awesome. Let's open our browser and let's go to port 5001. Yes, that worked. A few refreshes, 10 times. Let's go back to port 5000, the first instance, 15 times. All right. So let's do a Docker Compose ls again to list our projects. Now we have two projects. The first one that we deploy without specifying a project name, and the second one with the project name test. Let's delete our first instance by using Docker Compose down. So I didn't specify a project name. Docker Compose used the folder name as the project name. Now, if I do the Docker Compose ls, I should have only one project running. Yes, it's test. Now I can delete that one using Docker Compose, specifying the project name, and down. Let's list the projects again. Docker Compose ls. Nothing running. PS. Listing the containers. Nothing. And why not try Docker PS? Nothing in memory. In this lab, we will deploy a Docker Compose sample application that is composed of three services: a web frontend built with React, a Node.js backend, and a MariaDB database. Let's take a look at our Docker Compose file. This is more complex than what we saw so far, so let's try to break it into smaller pieces. Here we have the definition of our three services. If we start from the left, we have the backend service. Top right, the database, DB, and the front end. Now, if you look at the DB service, you can see that we're referencing an image that will pull from Docker Hub. And the other two services, we're using the build parameter. This means that we will build these two images. Looking at the backend service, we can see that we specify build and context. Context with the value of backend. Backend is actually a subfolder where the Docker file is located. Next, we're defining two networks, public and private. We can see that our front-end service is using the public network. The back-end service is using public and private. And the database service, the DB service, use only the private network. Front-end being in the public network cannot communicate directly with the DB service. But backend, being in both public and private, can communicate with both DB. And front-end services. We're defining also two named volumes, backend-modules and db-data. and we can see highlighted in the backend service is using public and private, and the database service, the DB service, use only the private network. Frontend being in the public network cannot communicate directly with the DB service. But backend being in both public and private can communicate with both DB and front-end services. We're defining also two named volumes, backend-modules and DB-data, and we can see highlighted in yellow that our DB service is using DB data, and our backend service is using backend modules. Highlighted in yellow, we also see that we're using other volumes. These volumes are scoped at the service level and are not shared between services. To create an instance of our Docker Compose application, we simply use Docker Compose up, and to bring it down, Docker Compose down. In Visual Studio Code, let's take a look at the Docker Compose file. So it's called compose.yaml. Here we have our services section, network section, where we define two networks, the name volumes, backend modules and DB data, and secrets that we haven't seen yet, where we're defining one key value pair. So the key is DB password, and we get the section compose.yaml. Here we have our services section, network section, where we define two networks, the name volumes, backend modules and DB data, and secrets that we haven't seen yet, where we're defining one key value pair. So the key is DB password, and we get the secret networks, the name volumes, backend modules and DB data, and secrets that we haven't seen yet, where we're defining one key value pair. So the key is DB password, and we get the secret from a file. The file is located in the folder called DB, and it gets the value from a file called password.txt. If we open the DB folder, here's the file with the value, the secret. And that will be injected when we run Docker Compose up. Okay, let's go back to the services section. And here we have our backend, DB, and front-end services. Let's take a look at backend. We're using the build directive, and we are setting the context to backend. It points to this folder called backend here, and the Docker file is located inside that backend folder with the application. Same thing with the front-end service, build, context front-end, and we're getting the Docker file and the application from the front-end folder. And what about the DB service? Well, we're using an image that will pull from Docker Hub. Okay, let's build our two images. We'll open a terminal and run Docker Compose build. And run Docker Compose build. Build our two images Okay, let's switch that will. And what about the from the front end folder? And what about the DB service? Well, we're using an image that will pull from Docker Hub. Okay, let's build our two images. We'll open a terminal and run Docker Compose build. Our images were built. Perfect. Now let's run the application by using Docker Compose up-d. -d Docker Compose up-d. Perfect. The application is listening on port 3000. So let's open a browser and type localhost 3000. Here's our React application. It's working. Awesome. We can list the containers that are currently running by using Docker Compose PS. We should have 3. Backend, DB, frontend. Awesome. Let's take a look at the logs from the backend service. Docker Compose logs-f backend. And these are the logs for our backend service. Awesome. We can type Control-C. To stop the log streaming, and we can take our application down by using Docker Compose down. This will stop and remove the containers from memory. Do we have something else in memory? we should we can type Control C to stop the log streaming. We can type Control C to stop the log streaming, and we can take our application down by using Docker Compose down. This will stop and remove the containers from memory. Do we have something else in memory? We should not. Perfect. Even if I type Docker PS, there's nothing. However, the volumes are still there. When you do a Docker Compose down, it will remove the containers from memory, but will not remove the volumes. So if I open the Docker desktop application and I click on volumes here, I can see that I have three volumes that were created a few minutes ago. So I need to delete them manually. I can select them right here and click on delete. Or I can do the same thing by clicking on the Docker icon in VS Code, locating the volumes here, and delete them. Find it easier to do that in Docker Desktop because we see when the volumes were created. So I'm pretty sure that these three are the ones that I need to delete. I'll click on the delete button. And confirm. Let's take a look at some of the Compose file features. It's a good practice to set limits on the resources that your container will use. In this example, highlighted in yellow, we tell Docker
Hey, do you want to see me build a Docker container? Yeah, let's do it real quick. Done. Want to see it again? Done. Man, that was fast. Docker containers. If you're in IT, you gotta know it. If you want to learn cloud, Azure, AWS, Google, Linode, DevOps, networking, systems, I think I said everything right, so I hope you have your coffee ready. In this video, we're covering three things. First, what the junk is Docker? Two, you're getting hands-on with Docker. I'm giving you access to a free lab thanks to the sponsor of this video, Linode. And then three, we'll go a bit deeper, talk about the big why Docker? All right, let's do it. Okay, what the junk is a Docker container? Whoa, we're getting ahead of ourselves here. Before we can define what a Docker container is, we have to first define what it's replacing. Virtual machines. What is a virtual machine? Now, many of you already know. Check the timestamps to jump forward, but we're going to cover what it is real quick. And I actually have a ton of virtual machines running on servers in my data center right now, and I've been meaning to get those servers out of there because I've been paying a high bill. I want to bring those home with me right now. Let's go get it.
I unplug.
Goodbye, data center. So here's one of my babies. Ugh, my servers. Now, before we answer the question, what in the world is a Docker container? We have to first talk about what's a virtual machine. Let's dig in. So this is my server. Traditionally, before virtual machines, you would install one operating system on this piece of hardware. Whew, bit dusty. All of the server's resources, from the CPU to the RAM to the hard drive, all of it was dedicated to one operating system, one server OS. So like I might just have Linux and this is my Linux server, or I might just have Windows. This will be my Windows Server 2016. Now, what's the issue with that? Well, none really, unless you want another server, another operating system. So before virtual machines, if you wanted a Windows server and a Linux server, you had to have two physical servers like this. So that's where virtualization comes in. Instead of installing one operating system, we're going to install something called a hypervisor. Now, a hypervisor is kind of like an operating system, but it only has one goal. Its goal is to help you carve up or divide your server's resources into multiple servers. Now, there are a ton of hypervisors, but the most popular one would be VMware, which is what I have installed on my servers, and specifically it's called ESXi. Bonus points if you tell me in the comments what this means, or what it stands for. And simply what it
Docker.
allows us to do is take a portion of our server's resources, maybe 2 gigs of RAM, 2 CPUs, 100 gigabytes of hard drive space, and this will be our Ubuntu server. And then on the same server, I can say over here, I can have one CPU, one CPU, 2 gigs of RAM, 40 gigs of hard drive space, and that will be my Windows Server 2016. And I can keep doing this until my server runs out of resources. Or I can even make these bigger, going from, I don't know, 1 CPU to 41. I mean, you can go crazy. Virtual machines are amazing and people use them every single day, but that's not how Docker works. In fact, Docker is kind of, well, not just kind of, it's different. When we use Docker containers, it takes us back to before virtualization. We're gonna install one operating system on this entire thing. So one operating system gets access to everything our server has to offer. But why do that? That's the big question, right? What is Docker doing? Here's what it is, and this is crazy. I'm gonna drop this line on you, okay? Where virtualization and virtual machines are virtualizing hardware, Docker virtualizes the operating system. What? What does that even mean? Now this right here is what we commonly see when we visualize how virtualization works. We have our hardware, we've got our hypervisor, and then we have our guest operating systems. But let me show you what Docker looks like. We'll always have our hardware, but instead of a hypervisor, like we just discussed, we're gonna have one operating system installed on top of this hardware, or onto the hardware. And let's just say for our case, we are going to install Ubuntu. Now, here we go. We'll then have our good old buddy Docker fly in and make some magic happen. Docker installs like any other application you might install on Linux. It'll be a process running or a daemon running. And then using Docker, we will virtualize portions of our operating system, in this case, Ubuntu, to create containers. Which, by the way, we'll define here in a moment, but they're really doing the same thing as these virtual machines over here. They have the same function and they have a lot of the same qualities, which is why it's kind of cool how they can replace virtual machines. Controversial, but that's what I think. And these containers, much like VMs, can be running a different operating system. CentOS, and even Ubuntu. You can install Ubuntu on Ubuntu. Ubuntu. What? Okay, but what are these things? What are containers? I like to think of them as crazy fast, lightweight microcomputers. And don't let micro fool you, like they can be as powerful as you want them to be. And similar to a virtual machine, they'll have their own operating system, their own CPU processes, their own memory, their own network. And the most important thing, and I think it's really appropriate for nowadays, is that they're quarantined. They are isolated. They are secure. As far as they understand, they are their own thing. They might as well be installed on bare metal servers because that's how isolated they are. Wilson, they're as isolated as you are right now. What, too soon? And let me say it again. These suckers are lightweight and they are wicked fast. Like you saw at the beginning of this video. Click, bam, whew, it's there. Now we'll cover why they're more lightweight, why they're faster, and more of why they're amazing here in a moment, but I think it's time. I think it's time you got your hands dirty, your feet wet, all those things. We're going to do that right now. Time to get your hands on with Docker containers. I'm so excited about this. You might say I can't contain myself. Sorry. Okay, here we go. Fire up your web browser. Go to the link below, linode.com/network chuck. And you get $20 of free credit, more than enough to play with Docker. So go ahead and create that free account. account and we will start labbing right now. Now, as I mentioned before, Linode is a cloud service provider. Very